Let us look at ReentrantLock first, and we'll use the same example as we used in the previous video. So here on the right hand side, we have a seat chart which we want to use to book a particular seat, and on the left hand side we have a set of threads which are trying to book the seat simultaneously. If we allow multiple threads to book a single seat, it's going to be an issue, and that is why we can use as one of the possible solutions a reentrant lock, wherein only one thread will be allowed to access the lock at a time. So in this case, all 4 threads will try to attempt or acquire the lock. Only one thread will be allowed to acquire that lock, and that thread, in this case the thread 1, which is the owner of the lock, is allowed to proceed. This thread will book a particular seat and it will release the lock. Once the lock is released, the threads thread 2 through thread 4, which went into the waiting state because the lock was not available, will now again become runnable. So very simple and straightforward. Only one thread is allowed to access the lock at once. All the other threads which are trying to access the lock will go into the wait state. As soon as the lock is available, they'll come out of the wait state and the rest of the threads will try to acquire the lock. And in terms of code, we'll create a new reentrant lock. Wherever we want to access the shared resource, we want to update the shared resource, we will acquire the lock before accessing that resource. And once the resource is accessed and updated, we will unlock. To understand the read-write lock, let's try a different use case. Let's say instead of all threads trying to book the seat, we want to allow a functionality where we are allowing the users to view the current seat chart of what seats are available and what seats are already booked. So in this case, let's say we have thread 1 and thread 2 who only want to view the seat chart, while we have thread 3 and thread 4, they want to book the seats. Again, as before, all the 4 threads will try to acquire the lock so that they can access the seat chart. Let's say in this case, the thread 1 is able to successfully acquire the lock and all the other threads go into the wait state. And thread 1, since it's the owner of the lock, will now proceed to view the seat chart. Now this is slightly inefficient because even thread 2 wanted only to view the seat chart. Both these threads are not going to update the state of the seat chart. We should allow both the threads to access the lock at the same time because they are only going to view it. So this would have been more ideal. Let's say we have a read lock, which signifies that we are only going to read the state, and we allow multiple threads to access or to own that read lock at the same time. And all the threads which have that read lock can go ahead and view that particular state, which in this case is the seat chart. And all those threads which were waiting to write or update the state, they will go into the wait state. Once thread 1 releases the read lock, and say after some time thread 2 also releases the read lock, that means the lock is now available to be acquired by someone else. And then the thread 3 and thread 4, which wanted to book the seat, will come out of the waiting state and will move into the runnable state. Once that happens, of course, since the lock is now available, they will try to acquire the lock. In this case, since both are writer threads, they want to book the seat, so they want to update the state. We will only allow one thread to acquire or to own the lock. So this thread, which is a single writer thread, is currently the owner of the lock, and now it can book the seat. So in this case, it booked this particular seat. And since the lock is not available anymore, the thread 4 will go into the wait state. And the same thing as before, if it releases the lock, the waiting threads will come back into the runnable state and will try to acquire the lock. So that's the basic difference between a reentrant lock and a read-write lock. A reentrant lock allows only a single thread to acquire the lock at a time, while the read-write lock has 2 functionalities. One is the reader lock functionality, one is the writer lock functionality. So in the reader lock functionality, you can have multiple threads acquire the read lock at the same time. And if it's a writer functionality, it's the same as reentrant lock. Only one thread can acquire the write lock at the same time. And the advantage of this is, as we saw earlier, if there are multiple reader threads who only want to view the state, allowing all the threads to do it at the same time will be much more performant because more threads will be running at the same time doing their jobs. In terms of code, it's slightly different than the reentrant lock. In the reentrant lock, we just created the lock and started to use it. In ReadWriteLock, out of this main lock, you have to create a read lock and you have to create a separate write lock. And as before, as we saw in the diagram, if there are two threads, T1 and T2, who are trying to read that particular state, and there are two threads, T3 and T4, who want to write or update that particular state. Both need to use different methods or at least different blocks. The read block will use the read lock and unlock methods to view the resource, while the write block will use the write lock to lock and to update the resource. Okay, and just like in the diagram, if these two threads T1 and T2 try to acquire the read lock at the same time, they will be allowed to access, both of them will be allowed to access the read lock at the same time. Both T1 and T2 will be able to view this resource, will be able to go into this block simultaneously. While in the write lock, only T3 will be able to go into this block, update the resource, come out of it, and then T4 will get the chance. And just to clarify, even though we have two separate locks, read lock and a write lock, there are two separate instances, only one will be allowed. So either you can have n number of threads accessing the read lock, or you can have a single thread accessing the write lock. But you cannot have both reading and writing done at the same time. What about the wait queues in reentrant lock? So behind the scenes, if it's a fair lock, all the threads which are waiting for that lock to be free will be put into a wait queue. In this case, thread 1 has the lock and thread 2, 3 and 4 are waiting for the same lock. Once thread 1 releases the lock, thread 2 will be the next because it has waited the longest. It will be allowed to acquire the lock. In case of ReadWriteLock, we have very similar structure. So we'll have the wait queue. We will have two kinds of threads. One thread which wants to read and one kind of thread which wants to write. Once thread 1 is done with its operation, the two threads, thread 2 and thread 4, both of which can be allowed to access the read lock because that is what is more efficient. But the thread 3 wanted to write, and that is why it is still in the wait state. Once all these threads which are owning the read lock are done with its operation, we will allow thread 3 to proceed and acquire the write lock. Now, while this reading is going on, while thread 2 and thread 4 are still the owners, let's say we have a new thread, thread 5, which wants to read. Now there are two options. One option is, since there is already reading going on, we can allow thread 5 and acquire that lock. The problem with this scenario is if there are new threads which want to read, keep coming in one after the other, then the thread 3 which wants to write will never get a chance. And that is why it depends on the implementations of ReadWriteLock, whether to allow this new thread to acquire the read lock or make it wait. Okay, and in our case, the reentrant ReadWriteLock implementation will do the latter. In the reentrant ReadWriteLock implementation, it will not allow thread 5 to acquire the read lock. It will still put it in the wait state. It will allow thread 2 and thread 4 to complete their task. It will then allow thread 3 to acquire the write lock. And once thread 3 has done its job, only then it will allow the thread 5 to acquire the read lock. Reentrant lock is a single simple lock, while the read-write lock has two separate instances of a read lock and a write lock. The reentrant lock has this facility of creating conditions, and so does read-write lock. The only caveat is read-write lock allows new condition only on the write lock. And the reentrant lock, as we saw before, is good for general purpose locking, while if your use case has a frequent reads and infrequent writes, then it can be more performant to use read-write locks. So that's it. That's the difference between reentrant lock and read-write lock. Thanks a lot for watching and see you in the next one. Bye.